we were talking about honing cylinders yesterday, and we talked about you have to hone them to a certain finish, which is called a what type of finish? RMS finish. And there were two ways I told you we could determine what kind of finish it had. One was to use a. We're gonna listen to Kevin say that. What was it?
Measured with a profilometer.
Profilometer. Okay, and the other way was
Surface roughness comparator block.
surface roughness comparator block, which was I had one, and you just did a little wallet. You open it up, and it had a bunch of metal in there, and all had different surfaces. And you just compared one thing to the other. Yeah, it looks like that one, and that's how it was done. So, huh?
Oh.
Yeah, the record player type thing. Never seen one of those. So that was 1, 2. I should maybe erased everything then. So 1 was RMS finish, 2 measured with, 3 honed to about a 45-degree crosshatch. So if you look inside of the cylinder, you will notice that it has cross-hatching. It's going 45 degrees one way and 45 degrees the other way. And that goes all the way down and through the cylinder. And so that's what I mean by cross-hatch at 45 degrees. So, let me see. Too smooth. What if you don't get that cross-hatching deep enough and the RMS finish is not quite enough? I feel like I'm missing one. That should be like an A, not a B, A. So too smooth. Too smooth, well, it will not hold oil. Will not hold oil. That would be bad. Also, you could have a problem with it not seating in the rings. So you don't seat in the rings. Well, it's kind of a chain reaction. So it's not rough enough, so it doesn't seat in the rings, because really, if we look at it from the side, this is kind of what the, magnifying it 100,000 times. That's what the cylinder wall looks like. It's got all these raised sharp edges, and the cross-hatching, of course, is the lower part. Then we have a ring that has to slide across that. And as it wears in, what it ended up wearing in like is instead of having a sharp point, it kind of has less of a sharp point. And those little I don't know what they look like there. That little cross-hatching is going to hold oil. Oil is red, of course. And so it holds just enough oil. But if you don't have a good break-in, then what happens is the oil actually comes out here and creates this film over everything. And then the ring just rides up and down on this super slick film of coked oil, and then you don't get seating and you get all kinds of problems. And then it becomes too smooth, and then it doesn't want to hold any oil, or oil can get through. And so you start burning oil and having problems. If it is too rough, so if too thin is bad, how about too rough? Is rough good?
Extra wear.
Yep, causes extra wear. Causes excessive wear. And that's bad. I don't know why this is 0.4 cylinder. So it's kind of interesting that if you actually read, and a lot of you really have, which is impressive, and again, I can't say enough about this class. That class, they suck compared to you guys. Tell them I said that. No, they were a good class too. Yes, tell them. Just go down there. No, they were good. They made all the engines nice and pretty, and actually they're in pretty good shape. So they were a good class too. But you guys are the class that really reads a lot and is well prepared. If you read about where to measure these cylinders, according to Lycoming, we'll look at the bore upside down. Here's the skirt coming down. Where am I supposed to actually be measuring? What does it say in there? It says what? Measure it about. It says what? 4 inches down.
4 inches down.
4 inches down. Okay, and then you're supposed to measure the choke. Where are you supposed to measure that?
2 inches.
Let's make this more realistic because it's more like this. Here, pen. So 4 inches down. That's about 4 inches, and it says to measure this.
2 inches.
Well, I'm going to tell you right now that from here to here is about 6 1/8 inch. So that means 2 inches up would be right about here.
Yeah.
So there's 2 inches. So do you really think that you want to measure 4 inches down to this spot and 2 inches up to this spot? Okay, that doesn't sound right. I mean, that's what the book says. So I just got to tell you, you got to do what the book says. But in reality, you know, I like to take my initial measurement right here, and then I compare that with, okay, 4 inches down is fine, but you have the bore gauge now, right? You know how to use a bore gauge, and you can see how quick it is. So I like to take measurements right about here, right about, and then another 4 inches down. So I can get a good view of what my bore looks like. Okay, there's nothing wrong with taking extra measurements at all. Nothing wrong. You know, you're never gonna get in trouble with, well, I thought you were only supposed to go 4 down. What do you mean you got extra measurements? You're extra careful. We can't have any of that. No, you can do that all day long. So number 1, I've got my measurement up here where I like to see it up here. 2, I've got this measurement here, which is really about 4 inches down anyway. And then I take my choke measurements right down here. Because if you remember, I'm telling you that when it chokes, too much stuff on here, it really chokes down here at the last little bit. And it doesn't do me any good to try and measure choke above that. I want to measure my choke where it's really choking down. And the reason why I really understand this is, I told you about my really cool hone machine. I wish I even tried to find a picture online. I can't find one. But in order to hone cylinders, we had this thing called a sine bar. And it was really just a piece of steel. It was about yay big, and we would literally pull it out of the machine, this piece of steel, and we would change them out for whatever cylinder it was. And they were labeled, like this one is for, you know, a Lycoming, and it would have the choke, a 10,000ths choke, or Lycoming 4,000ths choke. And so when you held up the sine bar, it was really just a profile of exactly what the cylinder looked like, but exaggerated. And then there was this little wheel that would follow it on the machine that would adjust the pressure. So you could really get a great representation of what the cylinder looked like. And there was absolutely, these sine bars were absolutely straight until the last little bit, when then they would pop in. So they look just like this. Oops, they had a little hook on it. Where they went in the machine. So you would see then the wheel for the machine, this probably doesn't make any sense, would roll up and down this, and when it got to this spot right here, it would release the pressure on the stones that were honing it, so it would choke it in. It's okay if you don't understand that. But my point is, I want to measure down here. I want to measure this part right here. I want to know. And for the same reason, I want to know what that choke is, because I don't want to be surprised that it was choked too much. The wear sometimes comes right down here at the last little bit and really gets a lot of wear right here in this. So if I'm measuring above the major wear part, I have no idea what's going on. I mean, it really wears a lot, that last little half of an inch. And this bore thing is critical. You want to hear a story? You gonna be okay with this, MJ? Yeah. Okay. So there's different machines and how they bore cylinders over. Some of them have a rotating wheel, like a grinder wheel that goes in a machine and it kind of goes around and rotates. The way our machine worked is you put it on, you do one at a time, and it had a head that was just the same size as the piston that would go in there. We have to change out the heads depending on. And it had 6 stones, 6 to 8 stones that would go all the way around the perimeter, and this ram would come up and press the stones out. And the stones are only about, I don't know, about that big around. They weren't real big stones. So, the machine would go up and down and spin and go and put the crosshatch. But to hone it out, you just let it run longer. And so it wasn't like I would program the machine and say, okay, I want to go 10 over. I would simply set it, and you'd have to had a counter on it. So you could set it for like 100 strokes or 50 strokes or whatever. So you'd set it for about 50 strokes or 100 strokes, and you'd set it. It would run through all of its strokes, and you would take it off and measure it. And you'd see where you are. Put it back on, do some more. Measure it. So maybe I go, I don't know, 400, 500, 600 strokes, but I do 100 at a time and check it. Because if you overbore it, guess what you do? You just throw it away and get another one, right? That's bad. So the procedure was, now when you're boring it, it's going to get warm, right? And so what happens when the cylinder gets warm? It expands everywhere, right? It expands at the head even more. So you really want to keep this profile right. So it was the procedure. My procedure was very simple, and my procedure is because of the story I'm going to tell you, was that, well, actually it was even before that. So the procedure has always been in our shop was, and in the shop before that they had the equipment, is you bore cylinders and you stop when you're about about 4 thousandths away or 2 thousandths away from your final bore. Okay, so now they're expanded, and so you want to stop 2 to 4 thousandths before you get there. Let them cool. When they cool, they're going to shrink back down, because the measurements that you're taking out of the book are room temperature measurements. Not, they didn't get terribly hot. They're about 100 degrees. You can hold them with your hands, but you don't want to very long when they're being bored. So anyway, so the guy in the shop before me, he had to bore over 6 cylinders for a Continental 0300 on a Globe Swift. A lot of my bad stories to have a Globe Swift. I don't know why I never owned one because of that. So anyway, so he had to bore the cylinders over. So he bores the cylinders over, and he did his whole thing, and he put them on the engine himself and did the whole top end and got it all ready. And the pilot came, test ran just fine. Pilot comes to pick up the thing, and because of our airport was a grass runway, it was just us. It was always fun to just go out and watch the airplanes take off. So I took a break. I come outside. I'm standing next to the guy. I remember like it was yesterday. It's been like 20-some years. And I'm standing there, and airplane, beautiful white Swift. It takes off, leaves our little grass runway, makes a turn, and look at that, smoke on. I look at I didn't know that thing had a smoke system on it. That's kind of cool. And he just turned white and he goes, it doesn't. Oh my God, I forgot to do the final bore. It was just like that. I forgot. He completely forgot. So he bored them the night before and stopped before they were the right size. So he's about 2 to 4 thousandths off. And he needed to bore them, finish it in the morning. And for whatever reason, he just never engaged with that. And so he installed he put them all together. And the thing ran fine on the ground. It's hard to believe this could happen, but it really did. So the thing ran fine. So the pilot, smoke on. And it's non-controlled. We don't have a radio. We can't tell him, you got to do an emergency landing. And he was going to executive. He made it. So I'll just tell you, he made it. So, we're just watching the smoke. And so Clarksburg is, it's inside the Class D airspace. So it's 4 or 5 miles there. Mm-hmm. So he's smoking the whole way. And we can't see him now. So we're on the phone right away. And so the pilot tells the story, new cylinders, new everything. He's watching. He goes, wow, he can see these temperatures just spiking. And it freaks him out. And he didn't want to come in and land on the grass runway again. So he's making it towards, you know what this is by chance? I don't remember who it is anymore. All right, so he's headed toward executive. And he, of course, called in an emergency. They gave him a straight-in approach. It's not that far. And he said as he's getting close, he said that all the temperatures are just spiked out at this point. And the power is going away. The engine's seizing up on him. And so he landed, and they tow it to his thing. So the next morning, I went with that mechanic to take the engine apart. And the way we had to take it apart was just brutal. So we would have to find a cylinder. We had to undo all the cylinders, and then we would find one that was near bottom center. And both of us would pull like on the prop, and we'd move that cylinder off of the case, and then we'd have to put 2x4s behind it and back the prop up and use it like a wrench to get the pistons out. It just destroyed everything. It was just an aluminum mess. So that's what 4 thousandths will do to your cylinder. That's all it was, 4 thousandths. How much is 4 thousandths? That much. It's off by that much. And it ate up that thing. So
did you guys as a shop have to cover it?
Oh, hell yeah. No, we just told him it was like that when we got here. Yes, yeah, we had to eat that. We had to eat it. Fresh engine overhaul. So, bad things happen, but you got to pay attention. So,
That guy lose his job?
no, he's a great mechanic. He's a great mechanic. Absolutely.
Everybody's human.
Everybody's human. Told you, I worked for a great guy. He used to say stuff like, you show me a mechanic that never makes a mistake, I'll show you a mechanic that didn't do anything all day.
Very true.
Yeah, it's the fact. So the fact is you're going to make mistakes because you're just human. I've made mistakes. The trick is to find a way to catch it before that happens. Mm-hmm. So that's where checks and balances come into place. So when I took over the cylinder shop, well, of course, I kept the same procedure. I always waited till the next day, cylinder's cool, do my final bore. But I had sheets for everything. I'm a paper kind of, I love sheets. I had so many sheets I would make up. I'd make one for everything. I even got down to the point where you came in, you said, well, I've got an 0320. All right, I got my 0320 sheets. And it would have like every part number, and I would just put like, I need 1 of those, 2 of those, 3 of those. Everybody else is writing and I had it all set out. So my cylinders, it had all the final QC things, everything about it, and including final bore. So somebody always had to check the final bore. Somebody else had to come in and look and sign it. And I would run through the thing and say, okay, here's the final bore. Let me show you. I'd measure it in front of them. They'd measure it. We'd look at it. Final bore. Here's the tech data, and they would sign it off. Even though I was chief inspector, somebody else to do it. There you go. That was a long story, huh? All right. So what is my point? Nobody even knows. My point was, because I wrote cylinder, and I was going to write cylinder wear. Cylinder wear is most near the head. Near the head. Due to heat and pressure. Due to heat and pressure. So I guess my point was, don't measure your cylinder way up here at the 2-inch mark. Measure it down here where you see the actual wear. And this is a great cylinder example. And you can see where the wear is on this one. If you look, there's this little ring that's only about, I don't know, 3/16 of an inch down. This is real. And you can see all that wear right there. And so yeah. Right? Or you can look right there. Look right there. I don't know. The chrome is. Actually, I should take that back. So let's look at it this way. So it's above. You have to look at it, but you have a line of chrome that's about 3/16, and then right on the other side, the chrome has been wore out. So right here and right over here, you can see there's not even any chrome. So if you run your finger down it, you're going to feel it right about here. In fact, if you look at it, there's no more cracks there. All the cracks have been worn through. So now I'm going to pass it out again. You look at that. That's where you should be measuring. So Steve's going to wipe my red pen off. So if I were going to be measuring this, I would want to measure right where my little red dots are. Exactly. Right up here for the camera. See that, Katie? No. So anyway, that's what we do. Want to hear a funny Katie story? She's going to listen. She says, well, I got to go listen to one of Dad's sermons.
Sermons.
She calls them my sermons. I love you, Kate.
Did you make her walk home?
It's a long walk.
Yeah, oh, it's not that far. I'll pick her up in a couple miles. Not that mean. All right, so we talked a lot about the cylinder barrel, right? And so that's the combustion chamber and all that. And you can take a look. How is the head and the barrel, how are they put together?
Screwed.
They're just screwed on. And so one of the things I tell you guys too much stuff. We have a lot of cylinders here, and I can always tell if it's a cylinder that I've worked on because there's certain markings that are consistent with the way I did things. And one of the things I was taught, the first thing you do when you get a cylinder, right before you put it in the oven, is we would take a punch, and we would punch a little notch in the head and a little notch in one of the fins on the barrel, because when you heat the cylinder up to where we're heating it, they'll twist. And if you twist that, that's not a good thing. You want them back the way they were, because think about it. Suddenly the head is all going this way. Then you got to get different push rods, and you have to get the angle. That's hard to do.
Two-piece with a bearing in the middle.
Yeah. All right, so we're talking about the cylinder head. And why it's B, I don't know. Just go with it. All right, so it's made of aluminum alloy. It is attached to the barrel. And is done with one. It is shrink fit. What does shrink fit mean? One is heated up. One is cooled. So you put one in the oven and one in the freezer. And you got to do it right, or they'll go together. So which one goes in the oven? Which one goes in the freezer?
The inner goes in the freezer. The outer goes in the oven.
Yes, the barrel goes in the freezer, so it shrinks. The head goes in the oven, so it expands. And you put the two together, you screws it together, and then when they both reach the same temperature, they're theoretically pretty well locked in place. Some shrink fit. Some of them do have a bolted flange. Not very many. Some radials, old-timey engines. They are threaded. I don't know, done, just so you know, done at high temp. 650 degrees is the number I have. And this is the most common. Most common method is the threaded shrink fit. Well, the head up there contains a whole lot of stuff that we have to talk about.
Would you ever just change the barrel?
Never.
No.
No, we were not certified to do that.
Oh, okay.
So you would think you could, and it would make sense if we just, but you have to send it to some place like, I sent a lot of stuff to Gibson Cylinders. They're still in business. And I don't know, he's a good guy. I like talking with that guy. They specialize in doing the kind of stuff to cylinders that a lot of places don't. Weld repair, so the head is cracked. I think they unscrewed them, and they would go in, because it's too hard to weld. They would grind out the crack, re-weld, heat treat, screw it back together. And I think when you chrome plate, you have to separate the barrel to chrome plate it. You can't leave it together. So places like Gibson, they would do all that.
How
So.
does one get like a license to do that from the manufacturer?
No, not at all. From the FAA. Manufacturer's not excited about you doing that. They don't like that.
Well, because they want to do it.
They want to do it. They want you to buy the new cylinders. So, no, you go to the FAA and write policies and stuff like that. Something with my glasses. Look like a buck. Just like I told you we could reface rocker arms, right? That's not an approved method, so how did I do it? You get engineering data, you write a procedures manual, you go to the FAA, and you say, I want to do this. And they may have their engineer double check your engineering stuff and goes through the chain. The engineer comes back and says, well, yeah, that's not going to be a detriment to anybody. And so the FAA will stamp that procedure. So now you're legal to do that procedure.
So now what happens if you approve it, FAA approves it, and then it's put into service, and then there's a death?
You're liable. But let's just be realistic. The real world. So the family is going to sue the engine manufacturer, the shop that did it, and the FAA for approving it. Gotta find the deep pockets. That's just the world we live in. What does it contain? It contains 1, spark plug bosses. Spark plug. There's that word again, bosses. So a boss is like a hole in something. Bosses. They are either going to be 14 millimeter or 18 millimeter. Why in the heck is everything in the world not metric until we get to spark plugs? Was it Japanese? No, we do, because NGK and all that. But no, because we'd have to go back to World War II. I don't think we were buying a lot of spark plugs from Japanese. What?
Back to World War One.
One. And who were we buying it from? Europeans, right?
The French, right? Did they come out?
That would make sense. The French. No, okay, I'm not sure exactly who it was, but in all actuality, what it is, if I get the story, we were making spark plugs, but we weren't very good at it. And really, if you read a lot of history, if I'm right, Alan, we were there, and it was kind of like
My grandfather was there.
okay, it was us and the French, us and the French, us and the French, right? That's why half the stuff we have on the aircraft is, as French names. Empennage. That's all I know. Yeah, fuselage, ailerons, empennage.
Yeah, that's American.
That's it, yeah, y'all. Anyway, so they were better at making spark plugs, so we started using spark plugs. And I guess, it was easier for us to make a 14 millimeter, 18 millimeter threads than it was to get them to make them in standard size. So that became the standard. So even if you go way, but I've never worked on an engine. I mean, as old as, I've worked on some that are like almost pre-World War II. They're still metric in that respect. So that's why spark plugs are always metric. So 14 is really rare. What size is your car?
5/8.
No. They're metric as well.
Not both sides.
Range size, not bolt size, they're metric.
Oh, we're talking threads?
Yeah,
Oh.
Yeah, probably
I don't know.
14.
My index finger, my helicoil looks like that. So
They're almost all, they're 14.
Yeah.
So we have 18. They're big. A couple of aircraft, old stuff, may have 14, but boy, it is super rare. I don't even know if I've ever seen a 14. I've seen maybe one out there. Otherwise, they're all 18 millimeter, which is pretty big. So they are, let's see, 18 millimeter. They have a brass or bronze bushing. And these bushings are kind of funny. And this is the old-timey engines. They have the brass or bronze bushing. I'll just put that old engines, like the old Continentals. And it's funny because they would do left-hand thread and put the bushing in backwards. So you have to go left to tighten it. All right. And then, so it'd be a big boss. They would screw that in, and then they would have then the hole for the spark plugs, and the spark plug screwed in. Well, sometimes the spark plug would seize up inside of the bushing, and the bushing would get loose. And so when you go to take out the spark plug, I guess it would be right-hand thread. Anyway, you take out the bushing, and that really messed things up. So I had to put the bushing back in. And that was never fun, but it's doable. Most of them have helicoil inserts.
Those would be like metric
Right from the, what's that?
Those are like metric helicoils?
Yep,
Okay.
right from the factory. They build the cylinder, they cut the helicoil, and put the helicoil right in. There's no messing around. It's not like they're bare aluminum threads. So, and you guys have 300. No, helicoils are better than just aluminum threads. A helicoil is a stainless steel insert, right? So they have helicoil inserts. And sometimes these helicoil inserts get all boogered up and seize up onto the spark plug, and you yank those out too. So what do you do? Put a new helicoil in, and they sell them, and that's not a big deal. What?
Get them in Napa.
Don't get them at Napa. Although it's funny, so don't get them at Napa, but they're probably the same. Probably. I'm not saying they are, because I wouldn't. I get them from an approved source. It's not worth losing my license.
Aren't they made by the Helicoil Corporation?
They sure are, but you don't have. Actually, when you buy the helicoils for the aircraft, they're going to have a mil-spec number.
Okay.
So that makes it an aircraft part. And
So what if we go to Napa and find a helicoil set that has a mil-spec number?
you still don't have an 8130s. I don't know. You're pushing your luck there. You're really pushing the envelope. Is it done? All the time.
Can't tell you how many people came in for belts and they're like, yeah, they're going on an airplane. But since I've been in this class, I haven't seen anybody. 'Cause I would tell them, I don't think I should sell this to you.
But if it's experimental, of course you can.
Oh yeah.
There's nothing wrong with it. So they make in 0320s, 0360s, like Cummings, they seem to be the more prevalent home-built engine because the RVs take them. Would you build RV what?
7.
What's the 7?
Side by side, it's like a 6.
Okay.
Yeah.
Tail wheel or?
Well, eventually when I get to the fuselage, it'll be tail wheel.
Okay. What's that? What engine is that going to have? 360?
Yeah, I like the 360 and the constant speed prop combination. I had a 170 with that, and it was just phenomenal.
I will tell you, my favorite engine is the 200 horse 360. That is
Is that single valve?
has the angle valve. Those things are awesome. But yeah, so there you go. It's going to be, you build a home built. You can go to you and get anything you want. Spark plug inserts doesn't matter, even though it's a light coming.
Yeah.
Goes on experimental.
Go to the aviation section in Napa.
Yeah. They have it. All right. So we have the spark plug boss. What else it contain here? It has the valve guides. And now you know all about valve guides. And when do we change out valve guides?
Worn or damaged?
There we go. Changed when worn. I'll put or damaged. Have I ever seen a damaged one? No. I've seen them worn so bad you'd think they're damaged. So, valve seats has the valve seats in it. Valve seats. When do we change those? Change when? worn, or damaged. So here's the thing about valve guides and valve seats. You can only change them out a couple of times. So valve guides, when the factory builds the engine or the cylinder, they're going to put standard size guides in. Then from there, you can go P005, which means what? 5,000's over. Then you may go P10, depends on the engine, P10, P15, P20, and P30. So that's, I think, all the sizes.
So the valves are always bigger and bigger.
No, valves are always the same.
Wow.
This is the outside diameter of the guide in the hole, in the cylinder.
I see.
So you pull out a guide, and you have to make the hole in the cylinder a little bit bigger,
Oh.
and the outside diameter of the valve guide is a little bit bigger, and that goes in there. So it was my shop's policy that every time you pulled a seat or a guide, you went to the next size over. I shouldn't say that because we'd measure them, and if there was any wear, and there always was, you almost always had to go the next size over. So how many times could I change out a guide? 1, 2, 3, 4, 5. For the most part. Well, be truthful, by the time you changed out a guide 5 times, that cylinder was pretty well worn out and cracked somewhere. All right, so valve seats came standard. I could put standard here. Standard. They came standard. P10, P20, P30. And every time we pulled seats, I remilled it, or machined it for the next size. So how many times can I change out seats? 3. And you're done. Only other option after that is weld repair and recut. And that wasn't really. So only change out valve seats when? Worn or damaged, not at overhaul.
So do you still have to grind the valve seats?
Yeah.
Like 3-angle or 2
Yeah.
angle?
Yeah.
Oh.
And you're like, 3-angle or 2-angle? I'm like, yeah. I'll show you. It depends on that. What else? We have the rocker arm bosses. And the rocker arm bosses have bushings in them. And how often do you change out those bushings?
On condition.
God, never if I could help it. I hated doing bushings. They're just very difficult to ream all the way through. Because you have to press them in. And it's just hard to press all 4 of them in. And then you have to line bore them. So rocker arm bosses, what's that?
Does the brass that you put in there like bend really easily?
No. Well, not once they're in, but before
No, like
that,
when
yeah.
Installing them, or is it easy to like bend
No,
them?
no. We had a tool that would hold them perfectly and then press it in. We have the intake port. How can I identify the intake port?
No fins.
Less fins, and larger. Has a larger opening. And we have the exhaust port. How can I identify the exhaust port? There we go. We'll just put this. So greatest amount of cooling fins. Greatest amount of cooling fins. Oh yeah, this is a good one. On Continental, so I'll put TCM because I don't want to write Continental. Continental spark plug points to exhaust. Only has one goes straight and one goes at an angle. And that angle one points over to the exhaust side. On the ones that point. Smaller diameter. Exhaust valve seat. Smaller diameter seat. Well, if I want to put that, I could put this and say larger diameter. Exhaust valve. Valve stem. So if you look at exhaust valve, it's got a much fatter stem with a very small head. And the intake is the other way around. Has a big old head and a very small stem. And you're going to say why? So I don't know. I'll tell you. Not right now. All right, let's talk about valves. I don't know why that's 6. It just is. Could be a G if you want it, but I know it says 6. 6, valves. Valves. Well, what do valves do? I like that. Use to, sometimes the simple works. Use to open and close. Close what? Ports. I love it. Ports. Which ports? Intake and exhaust. All right, let's talk about the parts of a valve. Parts of a valve. What number are you writing there, Janet?
I'm on A.
A?
Yes.
Exhaust port A?
Valve A.
Oh, valve. Oh, you're aware of it? Okay, so I can go all the way up like that?
Yeah.
Dang. Okay. All right, parts of a valve. Oh, boy. You know, it would be really nice if I actually had a picture of a valve and I didn't have to draw one because, you know, I'm just a great drawer. Let me see. Oh, well, I'll stop running by slides. We actually have one of these in the tool room. They're okay, but this is a piston pin remover from your piston. So you think about it. You know, you guys are doing an overhaul, and you have your engine, you know, set up like this. More often than not, if you're going to work in general aviation, you're working in a field, you're probably not going to be tearing an engine apart. I shouldn't say tearing apart, taking it apart. But you're going to be doing maybe a cylinder remove and replace, cylinder R&R. So you got a bad cylinder, you're going to take it off, you're going to send it to a cylinder shop, you're going to take it off, just put a new one on, right? You got to get the piston pin out. And you guys know that to take a hammer or a drift, even if you don't want to use the piston pin again and start banging on it, what are you going to bend? The connecting rod, and then you get all kinds of cylinder wear. So rather than banging on it, but I showed you how to use a little bit of heat, just press it right out. But if not, they make one of these piston pin removal tools. It's not bad, it's $80. I think this is from Aircraft Spruce. Used on Lycoming and Continental. And we do have one of these, but I just, huh?
The head is like ceramic or something?
No, that's a piece of rubber.
Oh, just rubber.
It's like a piece of rubber. Yeah.
But they cost $10 to make and they resell it for $80.
Yep.
It looks like it.
Big margin
Gotta make them.
Oh, hey, there's a great picture. Why didn't we look at this before? Okay. Let's talk about what we see here. So, what is this hole right here called that is created when this guide is removed? What is that hole?
Valve guide boss.
There we go, valve guide boss. All right, so we have the valve guide boss here. What is this hole that is created right here? Valve seat boss. Okay, that works that. So when I take out the valve guide and I bore this oversized, then the guide has to be a little bit bigger. If I bore this oversized, then the seat has to be a little bit bigger. But again, the stem never changes. They don't make oversized valves. It's just, that's the valve. It would be too expensive to do that. While I'm looking at this right here, I will tell you, is this the intake or the exhaust?
Oh, it's
Just wait till I nod. Yes, that is. Why is it the exhaust?
Because of the fins on it.
Got a lot more fins on there. What else can I look at?
larger stem.
Larger stem and a smaller head. Okay. This is an Allison cut seat because it's stepped. And Allison cut seats, this area right here is an interference fit. What does interference fit mean?
They won't fit.
Go ahead.
It won't fit, like, you have to either freeze one or heat one up.
There you go. All right. Shrink fit.
It'll interfere.
Interference fit. So in other words, if I measure the opening of the cylinder, I take out the seat and I measure the seat boss, and I measure that and I measure the seat, I'm going to go, the seat is actually bigger than the hole it has to go into. That means that's why you have to shrink one and heat the other. So that's an interference fit. But this area right here is not an interference fit. That is actually, that's terrible. That is, I thought I could erase it. Yes, sir. So this area right here, down below, that is actually not an interference fit. And the idea behind that was, and most cylinders are this way. So right, if I can do it right there, not an interference. It's actually, you can even see, well, if you really use your imagination, you can see that there is a space there. And there we go. Whoosh. There's a little space there, but it looks like there's one up here anyway. A little space there. And the reason why that is that way is it relieves the stress that's built up within the cylinder and you're less prone to cracking. in that area because exhaust seats are prone to the cracking.
So it's only the top part that's an interference.
The top part is interference, the bottom part is not. Not that you need.
Does it also allow for expansion, like with heat?
Well, that's why you have. I mean, well,
Like on
that's.
the bottom part?
Yeah, that's why that's why it's that way. Because they expand at a different rate, and that can create cracking. Because one's steel and one's aluminum.
Wait, so is that like a cutout? I'm kind of confused.
Yes, it's a cutout.
So given our
See,
policy-
it's right here. You see this right here?
Yeah.
It's enlarged right here. That's this right here.
Okay, I thought. That makes more sense, but like, wait. That's not
If you attempt to do a compression test on the cylinder, it's going to read low.
I'm not talking about the cutout with the image. I'm talking about the cutout, like what you circled. Is that like is there a cut? Like the,
It's just a cutaway.
Yeah, the whole thing's been cut.
where you circled the little like L.
Yes, that is where the valve
They used to be
seat goes.
a perfect circle. They cut it so you could see it.
He's talking about where the actual valve seat sits.
All right, I don't
Cut
know.
that way.
So how you put the seats in the box?
Well, I'm going to show you. That's what we do outside the class. So, all right. So back to this. Oh, wait. You guys, you want a break, huh?
The ones that we had were just like.
Yeah. Dang it.
Yeah.
It's just like a straight flat. That one has the L, because that's